Okay, so welcome to the 10th class of Computer Architecture and Organization. Now we are going to discuss about the topic called Basic Input-Output Operations. So this is the name of the topic, Basic Input-Output Operations. So actually this is a very, this is a very easy topic, but you need to concentrate a little bit. Okay. So if you concentrate a little bit, then everything will be easy. Everything is known to you. Actually, simply to say, whatever the topic I am going to cover on this day, it is known to you already. But now we are going to discuss that particular topic somewhat technically. Okay, there will be some technical terms that are added to the already known topic. Okay, so the name of the topic is basic IO operations or basic input-output operations. So you all are very much familiar about what is meant by a input unit and what is meant by a output unit, isn't it or not? So what is an input unit? The unit, what are input units means? The units by using which we are going to do the input to the processor are called input units. And from where we are going to get the output from the processor, those will be referred as output units. So this is the concept which everyone is very much familiar, isn't it or not? So the best example for input units are mouse, keyboard. So these are the examples for input unit, whereas monitor, printer, these are the examples for the output unit. Now in this class, we are going to discuss how the data is going to be transferred from one place to another by using this IO, or what are the various IO operations that are to be performed. Okay. So here the basic thing what we need to discuss is, first of all, the data will come from the input devices. Okay. So for example, consider it is a keyboard. Okay. So keyboard is one of the example for input device. Okay. So from this keyboard or whatever the input device, the data used to come. Okay, through. So here it was mentioned as data in. That means from this keyboard we are going to get the input data. We are going to get the input data. Yeah, and on some spotlight. Okay. Yeah. Okay. Here we are going to get some input data. Similarly, the input data what is present here, it is going to be transferred to processor from input device to that means from input device keyboard, it is going to transfer to a processor. Okay, where the processor is going to perform the required task or desired task or whatever the task that is assigned to you on the given values that are obtained from the input device. The input device may be keyboard or it may be mouse, whatever it may be. So it is going to perform the required task from these things. Yeah. Okay. So whenever I am performing some operation, that means whenever I am giving some input, I have to give it by using the input device. Okay, that will be referred as data in, input data. SIN means serial input, that is going to be transferred by in a serial manner. So it will be referred as SIN, serial input. Okay. So it should reach the processor. How can it reach the processor? Means by first of all, this is the common bus. Here we can observe there is an indication with red line and black line. It is a common bus. That means whatever the data that is transferring through this common bus, anyone can share. Anyone can share. Okay, now. So first, what it is going to happen means the input device, that whatever the data we have entered by using the input device, it is going to be transferred to the processor through this common bus. Okay, now. Next, the processor is going to perform the desired task on the obtained input value. That means it may either perform the addition, it may either perform the subtraction, division, whatever that may be. It is going to perform the some task, and they obviously will get the result. Okay, that result either it should be displayed by monitor, or if you want to get any printout, it should be transferred to printer. Okay, so from processor the data or processed data is going to transfer to this data out by using that same common bus. See, if you observe from this common bus, by using this common bus, the data, the input data is transferred to processor, and by using the same common bus, the data transferred from processor to output device. Okay, here SOUT means serial out. Okay, and you are having a display unit. So it may be display unit like monitor, or it may be printer where the output is going to be displayed. So this is very what you will call generalized topic, where you all of you know very well, isn't it or not? If you try to enter something on your keyboard, isn't it or not? Obviously, whatever you press on your keyboard, it is going to be presented on your monitor screen. This is the thing that is going to happen in our day-to-day life. So I think most of you have either laptop or personal or desktop or whatever it may be, or if you have any mobile, then also you can observe whatever you are going to enter by using the touch screen, that is going to be displayed in the screen itself, isn't it or not? So how it is going to happen means, first of all, whatever the data you are going to enter in your keyboard, it is going to be transferred into ASCII value. The full form of ASCII is American Standard Code for Information Interchange. The full form of ASCII is American Standard Code for Information Interchange. Okay. So first of all, so here we are having some example. So what is mean by basic IO operation? What is mean by basic input output operation? What does it mean? Here we have given some information. That's the information what we have given is already known to you, but as it is a topic in our computer architecture and organization, it is my responsibility to discuss. Okay, so you can easily understand with a cool mind. There is nothing difficult task in this class. It's a very easy and simple class. Okay, so what is mean by basic IO operation? It deals with the means by which data are transferred between memory of a computer to the outside world. Here, see, if you observe here, it deals with the means by which the data are transferred between. So the data is going to be transferred between two ones: memory of a computer and outside world. Memory of a computer and the outside world. Okay, na? That means it may come from outside world to the memory, or it may go from the memory to outside world. Here, if you observe 2 points, first one is outside to world to memory. That means from where it can come to the memory, by using some input devices, isn't it or not? From input devices to processor to memory. It may either transfer from memory to the outside world, means from memory it can be transferred to outside world through a output devices. That means by using the input devices and output devices, we can transfer the data. Okay, na? So as it is very important, that means data transfer between input and output are very important. These are called essential operations. These are called essential operations. Okay, na? So how can I decide the performance of a computer? How can I say whether my computer is in good condition or not? Okay, or how can I say this particular computer what I have purchased is good one or not? Is first feature is its performance. Performance. How can I evaluate the performance? How can I say its performance is good? Means how it is performing input output operations, how fast it is performing input output operations, how accurately it is performing input output operations. Okay, so based on how it is performing the input and output operations, based on that phenomena, I am going to evaluate my computer whether it is good computer or bad computer. Okay, so that's what it was mentioned in this point. The way they are performed have a significance on the performance of a computer. What they have performed, that is nothing but IO operations. How a computer is going to perform input and output operations, how fastly, how accurately, okay, it is going to perform, depends on that only performance of the particular computer is going to be depending. Clear? Okay, next. Yeah, basic IO operations. Here they have given one simple example. See, I want to transfer a data from my input device to output device. How it is going to transfer? That means If I want to type my name Krishna, 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 okay. So how can it is going to transfer from keyboard to the printer monitor? That means I want to display my name. I want to see my name in the monitor. Okay. So for that purpose, I have opened some MS Word or something. Now, what is the thing I have to do? I have to type the letters in the keyboard. Okay. So how the letters are going to be printed in a monitor? Whenever I type some letters, how they are going to be printed in the display in the monitor. Okay, that's what we are going to discuss now. Okay, there is a what we will call there is a intermediate. There are many number of intermediate tasks in between. So how they are going to happen means, first of all, whatever I enter by using a keyboard. Okay, so they are to be. So here they have given now. Consider task of reading characters from the keyboard and produce characteristic outputs on the screen. Here my task is I have to enter some characters. Those should be read by the processor, and those characters are to be displayed on the screen. That means whenever I type KRISHNA, our processor has to read those characters. That means reading the characters means it should know what I have typed, what characters I have typed. That will be referred as reading the characters. Okay. So first, what it has to do, it has to read the characters. Then it has to display on the screen. That's what it has to be performed. Okay. So what they are telling means, first of all, whenever I enter a letter, that means I want actually my main thing is to enter Krishna, Krishna. Okay. So first I will type K. That means after K, I will type RISHNA like that. I know typing, so somewhat to some extent, so that I will enter KRISHNA at a time. Okay, one by one within no time. But how it is going to be display on the monitor? There is an intermediate process that is going to happen. What is it means? Whenever you type the first character, that means whenever I type K, what is the thing that is going to happen means it is going to be the processor sends the, you see, there is a speed, the best method to perform is program control IO. There is a speed difference between typing speed and the user and the processor speed. The processor sends the received first character and then waits for the signal for the display that the character has been received. There's something I have read very fast, you know. So what is the meaning of that? That one means, see, I used to press K. Okay, and I have told now the speed of my, or let us assume a person who don't know the typing. Okay, so first he typed K. Later on he searched where is R. He typed R. Later on he searched I. Like that he typed one by one. Okay, here what is the main concept is, first of all, whenever you type the K, the particular processor will receive that K. Okay. How it is received means it is going to receive the ASCII value of K. This is the thing you have to remember. ASCII means American Standard Code for Information Interchange. Okay, na? Here, if you observe in the keyboard, there will be ABCDs like that, na? So if I type A won't transfer as it is. Okay, na? The ASCII value of A is going to be transferred. Whenever I type B don't go transfer as is. The ASCII value of B is going to be transferred. I think you are very much familiar about this concept in your C programming. Okay, na? So see, if you observe my typing speed, there will be a speed difference between my typing speed and the processor speed. Okay, processor speed is very much high compared to the speed with which I am entering the characters. Okay, so then what is the thing that is going to happen? Whenever I type K, obviously the processor will receive that ASCII, corresponding ASCII value. It will send that particular information to the screen, or what we will call a monitor. Okay, now. So once it transfers that particular information from processor to monitor, then it will wait for what? It will wait for the second character to come from the particular input device. It will wait for the second character to come from the input device. Okay. So whenever it receives the second character, then it will display that particular second character in the it will transfer that particular second character to the monitor, and again it will wait for the third character. That means if you observe, there is a speed difference between the person who is entering the data and the processor of that particular computer. Okay, the person speed may be less compared to processor speed. Okay, that's what they have mentioned here. The processor sends the received first character. That means whatever the processor receives, that means first it will receive K. It will send that character and waits for a signal for displaying until that character has been received. So what it is going to do means, first whenever it transmits K, see, I am the person who is typing. For example, I entered K. Okay. So then what is the thing that is going to happen means, if that particular K is going to be transferred from my input device to processor. Okay. Then what the processor is going to do, the processor will transfer the data to the output device. Okay. Then what is the thing that is going to happen means, that particular K has to be displayed on the screen. Okay. Whenever this particular K is displayed by the output unit, then the output unit will send an acknowledgement or send any signal to the processor that whatever the K you have transferred, I have printed it on the monitor. Like that, it will transfer one signal. Okay. Whenever the processor receives the signal, then only it will accept my R. Then only it will accept my R, what I have typed second. Okay. Though I might have finished typing KRISHNA in this meantime, but the processor will accept my second letter R only after the completion of my completion of displaying of my first letter K on the monitor. Okay. Once the processor receives the what you will call signal from the monitor that if the K is printed, then only it will accept the second character R from this input device. Okay. Up to then, that particular rest of the characters are in buffering mode. Okay. So next it will accept the second character R. Second character R. It is also going to be displayed in the output. Okay. So whenever it receives the reply signal, or whenever it receives the signal from the display unit, that means monitor, that your second character is also printed, then only the processor will accept the third character. Like this, the data is going to be transferred from input device to the memory, and from memory to the output device. I think it is very clear to you, right? Similarly, R is going to be transferred from processor to memory, memory to monitor. Okay. Sorry. Input device to processor and processor to output device like monitor. Okay. Similarly, ISHNA, so that the entire word Krishna is going to be displayed on the screen. Okay. So this is the basic IO concept. That's what I have mentioned here. See here, our concept starts here. There is a speed difference between typing speed of the user and the processor speed. That's what I have mentioned. There will be a difference between processor speed and the user speed. That means I may type the letters with some speed and the processor may execute with some other speed. Okay. So what is the thing that is going to happen? The processor sends the received first character. That means whenever I type KRISHNA, first it will receive K and sends it to the receiver. It is going to send it to the receiver, and it will wait until for a signal for displaying until the character has been received. That means once if it transmits K, it will wait until it receives a signal from the what you will call output unit. What you will call output unit, that your K is being printed. Okay. Once it is over, then it is going to transfer the second character. Okay. Whenever it will again receives a signal that your second character is also transmitted, then it is going to transmit the third character, and so on. I think it is clear. Okay. One block of instructions in IO program transfers characters into the processor. Another associate block of instructions causes the character to be displayed. That means one block of instructions means from input to processor, there is a transfer of data. Similarly, from processor to output, there is a transfer of data. That's what they have mentioned here. Is it clear? Okay. Next here we have to discuss about D out and S out. Okay, na? Whenever S out pin is 1, that means the processor completed the transfer of data to the output device. As I have discussed previously, the processor will transfer the data from it to the output device, isn't it or not? Okay, output device means monitor. Okay, so whenever it transfers the data, it will wait for the acknowledgement signal. It will wait for the acknowledgement signal. I have told now. It will wait for the signal from the output device. Okay, that signal is nothing but DO, S out. That signal is nothing but S out. Okay, whenever the processor receives S out signal as 1, okay, that means whatever the data it has transmitted, that is completely received by that particular output device. Is it clear? Okay. And whenever D out is equal to 0, that means when data is transferred, that means whenever the data is transferred, S out is going to be 1 and D out is going to become 0. These two things will happen when the data transferred from processor to the output device. Okay, is it clear? Okay, next. Yeah, next we are going to discuss about various types of logical instructions. These are also very important as far as CAO point of view, and afterwards continuation microprocessor, microcontroller, PIC, ARM. Wherever you go, there will be arithmetical instructions, there will be logical instructions, there will be branching instructions. The notations may change and there may be small differences in its operations, but the common theme of these logical operations are same in all the processors and all the controllers. First of all, what operations will be referred as logical operations, isn't it, Anna? So you all are very much familiar about the subject called switching theory and logical design, STLD. Okay, so in that STLD you are having basic logic gates like AND gate, OR gate, NOR gate, exclusive OR gate, like that. Okay, here also we are having the same or similar logical instructions like AND instruction, OR instruction, NOT instruction, exclusive OR instruction. Okay, the concept of these logic gates, logical instructions are same as that of logical gates what you have learned in your STLD. So whatever the function of the logic gates you have learned in your STLD, that function is similar or it is same to the instructions what we are using in this particular CAO. Okay, that means whatever the operation an AND gate will do in your STLD, the same operation is going to be performed by AND instruction in a CAO. Whatever the operation an OR gate will perform in your STLD, the same operation is going to be performed by OR instruction in CAO. Whatever the operation a exclusive OR gate is going to be performed in your CAO, that same operation is going to be in your STLD, the same operation is going to be performed by exclusive OR XOR instruction in our CAO. Okay, so what are the logical instructions means? AND, OR, NOT, if you include exclusive OR, XOR, these are the logical instructions. Okay, first of all we are going to discuss about one by one. Among these instructions, AND gate and OR gate requires at least 2 inputs. AND and OR gates requires at least 2 inputs, whereas NOT gate requires only 1 input. 1 input is sufficient for the NOT gate. Okay, so first of all, the syntax of NOT gate is NOT space destination. That means here NOT is an operational code. I think you are very much familiar about what is meant by opcode and what is meant by operand from your previous classes. Okay, so NOT is an operational code and the destination is an operand. Okay, so what is the function of a NOT gate is it is going to perform the 2's complement for a given value. Whenever you write NOT and if you specify any operand, this particular instruction is going to perform 2's complement for that particular operand or particular instruction. Okay, that means if I write NOT space R0, here if you observe, R0 is a name of a register. Okay, if the value of R0 is 9H, H indicates hexadecimal number, I think you all are familiar about binary number system, octal number system, decimal number system, and hexadecimal number system. Okay, so 9 is an hexadecimal number here. Okay, so whenever I apply NOT gate, it is going to perform 2's complement on that particular given value, and it will store the value in that particular register which we have mentioned. That means it is going to update the R0 value with the 2's complement of R0. Initially you might have R0 is equal something, and whenever you write the instruction not space R0, it will replace this 9H with some value which is equivalent to 2's complement of 9H. So here, first of all, what I have written means, see, 2's complement and 1's complement are they were related to the binary number system. I think you all are familiar now. 2's complement and 1's complement are the concepts that are related to binary number system, isn't it? 9's complement and 10's complement are related to decimal number system. 15's complement and 16's complement are related to hexadecimal number system. So what is the first thing I have to do? First of all, in order to perform the 2's complement, I need to convert my hexadecimal number into binary form. So as you know, 8421 code, so the equivalent value of 9 is 1001. So not's complement will perform 2's complement. So if you observe, 2's complement is nothing but 1's complement plus 1. Isn't it or not? So 2's complement is nothing but 1's complement plus 1. Where I can get something to draw. Yeah. Okay. No need. Okay. So 2's complement is nothing but 1's complement plus 1. Okay. So the 1's complement of this one is going to be 0 double 1 0 0 double 1 0. Okay. So 2's complement means I have to add 1. I have to add 1. Okay. So whenever I add 1 to this one, it is going to become 0 double 1 0 plus 1 means 0 triple 1 0 triple 1. Okay. So this is how we are going to get the value. Okay. So this is way of getting the 2's complement. Okay. So that is the purpose of this one. Which one? Not instruction will perform the 2's complement. 2's complement means 1's complement plus 1. Okay. That means first of all the value which we have represented in the hexadecimal number, it is going to be converted into binary form, and afterwards it is 1's complement is going to be performed on that number, and we are going to just add 1 to the least significant bit so that you will get the 2's complement. You know about this very well in your STLD. Okay. Next one, AND and OR instructions. So AND instruction will perform logical AND between the given values. Okay, bitwise logical AND. What does it mean? See, here I have taken an example of AND R0 comma R1. That means the AND operation is going to be performed between R0 and R1 registers, and the result is going to be stored in the R0 register. Okay. The result is going to be stored in the R0 register, because whatever the register that was written in the first place, there the value is going to be stored, because its syntax is AND space destination comma source, AND space destination comma source. Okay. So what it is going to perform? It is going to perform bitwise AND operations. What it is going to perform? Bitwise AND operations. What is the meaning of this bitwise AND operations? Means here, observe carefully. If consider R0 is equal to 8H, which was written as 1000, similarly R1 is equal to 3H, 3 can be written as 0011. How we have written this one? I think you all are very much familiar. We have to write 8 4 2 1. We have to write 8 4 2 1. Code. I think you are very much aware of this one. That's why I'm not stressing this concept. How can I write 8 as 1000 means you are having 8 4 2 1. How you will get that 8 4 2 1? 2 power 0, 2 power 1, 2 power 2, 2 power 3. Okay. So here what I am going to perform is I am performing bitwise AND operation. That means first of all, what is the concept of an AND gate? The output of an AND gate is 1 whenever the given two inputs are given inputs are 1. That means whenever the inputs are high, all the inputs are high, then only the output is going to be high. Okay. Here also the output will be 1 when both the inputs are 1. Okay. But here if you observe, here the input is 0 and here the input is 1. So both are not 1s. So output is 0. Similarly, 0 1. Here also output is 0. 0 0. Output is 0. 1 0. Output is 0. So altogether you have got a 0 0 0 0 H as an output. Okay. If you consider the same example with an OR gate, the OR gate will have an output. It is also going to perform bitwise OR operation. That means the output of this particular OR gate is 1 when any of the input is 1, not both. When any of the input is 1, then the output is going to be 1. Okay. So if you observe here one input is 0 and other one is 1, so obviously the output is going to become 1. Here both the inputs are, here one input is 0 and other one is 1, here also the output is 1. Here both the inputs are zeros, so output is 0. Here one input is 1 and the other is 0, so as one of the input is 1, the output becomes 1. So 1 0 1 1 means as per 8 4 2 1, it is 8 plus 2 plus 1, that means 11. So it is not hexammer. H I have written this is by mistake. Here there won't be any H's. It is a binary form, so these H's are not there. It is my mistake. Okay. So answer 1 0 1 1. That means 8 plus 2 plus 1. That means 11. 11 can be represented with B because the value of A is 10 and B is 11. Okay. So these are arithmetical AND operations. So logical AND, logical OR, logical NOT. Okay. Why these are called logical operations means they are just like logic gates. Okay. As we have discussed in the STLD, these are very similar to the logic gates. Okay. We'll we'll stop here.